Okay, good evening guys. So welcome to another session of Azure Online the class, and in this session we are going to learn the virtual machine concepts, which is actually an extension to what we discussed during the demo. So in the demo we have seen how to create a basic virtual machine, and how do we connect that to a storage account and all that, right? So today we are going to see a different side of the virtual machine. So how do we manage failures? That means, let's say you have an application and you have one or more web servers for it, right? So what happens if one of the web server is down? So automatically there should be a piece of equipment which should transfer the load to the second available web server, right? Because in an ideal world, applications which are running on the internet 24/7, we should have more than one servers running the application, so that one there will not be a single point of failure, right? So if you look at the diagram here, on the left hand side we have the typical on-premise network. That means in every office we have a router, and behind the router there is a firewall, and after that there is a load balancer. Under that we have web servers. So there could be more than one web servers. Depending on the size of the application, it could be 5, 10, 20. It depends on the application, right? So similarly, if you want to do the same thing in Azure, you can do that, right? So web servers are your typical VMs. You just create VMs and then enable IIS on them, and they become your web servers, and install your website and whatever that you want to, and the web servers are running. But how do we create an infrastructure which will help you to do failover? That means if one of the VM is down, you should automatically send the traffic to another available VM. So that is the job of a load balancer. So in Azure we have a component called load balancer, and that load balancer connects to all the VMs which you have created, and it actually checks the health of the VM every few seconds or few minutes. You can configure it, and then if any of the VM is down, then the traffic will not be sent to that VM. It will be sent to a different VM. So we are going to learn that today. Okay, so we'll go back to the Azure portal, and then what I'll do is I'm going to create couple of VMs. Okay, I hope you are familiar with this VM creation process. I go to compute and I go to operating system, and I select one of the operating system, that is 2012 R2, and I give some basic settings that I need to create a VM. So I give all the required details here. Okay, and I select my data center. So all this you're already familiar. Okay, size, even I'll pick something of this size. They should be fine. Virtual network, I have not come to this point yet. I will let you know. Okay, availability set. So this is something that we are going to learn today, right? Availability set. So previously when we created a VM in the demo session, we didn't create any availability set. We just went with the none option, right? Now we are going to talk about a scenario where you have more than one VMs and all are working in a failover mode. So for this kind of setup, you definitely need an availability set, right? So what is an availability set? So I'll just click on create. I'll just say some name, set1, and you have these two important settings: fault domain and update domain, right? So fault domain assigns the number of UPSs, or the number of storage servers or networking servers for your VMs. Okay, so to simply explain, if you have 10 VMs and you don't define an availability set, it could be possible that all 10 VMs might be created on the same server in the data center side, or all 10 VMs are going to the same UPS, or all 10 VMs are going to the same network switch. So what if that network switch goes down? What if that UPS burns down, right? All your 10 VMs are gone. That could be the scenario when you don't create an availability set, right? Now let's see the same scenario with availability set. Now I mentioned default is fault domain 2 and update domain 5. First I'll explain fault domain. So I'm mentioning 2 as my fault domain number, and I'll take the same scenario, 10 virtual machines. Now with this setting of 2 fault domains, what happens is 2 UPSs and 2 network switches and 2 servers are allocated for your VMs. That means 5 will go to one of the server from a different UPS, 5 will go to another server from a different UPS, 5 will be connecting to one network switch, 5 will be connecting to different network switch. So there is no single point of failure. So even though one of the UPS goes down or one of the network switch goes down, at least 5 VMs will be available to you. Okay, so that is fault domain. So the maximum number you can allocate for a fault domain is 3. The maximum number you can allocate is 3. My subscription doesn't allow me to go to 3, but the max you can go is 3, right? So 3 means if you have 10 VMs and you choose a fault domain number of 3, then the distribution will be something like 334 or 433. So in that case, if one of the UPS goes down or one of the network switch goes down, you will at least have 6 VMs available to you or 7 VMs available to you. Okay, making sense? Okay, so let me explain the update domains. Update domains is for your Windows updates. Okay, since you are leasing the virtual machines from Microsoft data center, and those are running with Microsoft OS and Microsoft platforms, updates are pushed to the servers on regular basis. So your VMs might reboot more than once in a week, or probably more than once in a 15 days, right? So what happens if all the VMs reboot at the same time because of the updates? That is also a failure scenario, right? What happens, you have a Flipkart big sale you announced and Microsoft is rebooting your VMs, your business goes for a toss, right? So to prevent that from okay, let me check. Okay, so I was just explaining update domains. So what happens if Microsoft reboots all your VMs because of updates, right? So that is also going to cause a problem for you, for your business. So to prevent that from happening, you allocate update domains. So what happens in update domains is, let's say if you start with this default number of 5 and you have 10 VMs available. So if you have 10 VMs available, one slot will have 2 VMs because you have 5 slots here, right? 5 update domain slots. So one slot will have 2 VMs. So what Microsoft does is, they will reboot one slot at a time. That means at any given point of time, only 2 VMs will reboot, right? If you want to reduce the number of VMs that you wish to reboot, you can increase the number of update domains, right? Let's say if you make it 10, what happens? One slot will have 1 VM. That means only 1 VM will reboot at any given point of time. So if you don't care about how many VMs you reboot, it is fine, then you can go with a lesser number, right? If you go with a lesser number, then what happens, with this update domain setting of 2, you will have 5 VMs in each slot, 5 in the first slot, 5 in the second slot. In that case, if reboot happens, the 5 VMs are not available to you. So similarly, this is simply a ratio. If you have 20 VMs, you'd simply divide with that number, and that is your availability set. At any given point of time, Microsoft guarantees that those many number of VMs will be available to you. But if you don't create an availability set, so by default the availability set number is 0. I'm sorry, by default the availability set is set to none. So you cannot go to Microsoft and claim for the 99.9% availability, because Microsoft gives you 99.9% availability provided you create an availability set for your VMs. If you don't create availability set for your VMs, Microsoft simply will not accept your request. That means you cannot sue Microsoft because you have not created availability set. So if you don't create availability set, Microsoft don't know what is the purpose of these VMs. If you are going to use it as a cluster, you definitely have to create an availability set. So when you create an availability set and you select this availability set for all your VMs which you are creating, then Microsoft ensures that the number of VMs which is going to distribute, right, for each server, for each network, will be different. That means if you don't create availability set, all 10 machines may be created on the same network switch, same server, same UPS, and the end result is disaster. That means if you are creating a cluster using those VMs, then it is a problem, right? So to prevent being in that situation, we create availability set. Okay. So network security group I already explained in the last class. So this is simply a firewall. So I'm not selecting a firewall for now. Okay. So I'm going to create one VM. Okay. So this already explained in the last class. How do we create a VM? And the only option which I changed this time is the availability set. So you have two options, fault domain and update domain. So I've made settings for both. Now one of my VM is getting created. Okay. Okay. So server 1 and server 2 both are pointing to the same availability set which I created. So availability set is set 1, right? So whatever I created during the VM creation. So I have two servers. One is joining the domain 0, one is joining domain 1. So I have selected 2 as the value for fault domain, 2 as the value for update domain. So now I have two machines overall, right? So one will be assigned here, one will be assigned here, one will be assigned here, so something like that. Now if I keep adding more machines, then the distribution is equal to fault domain 0 and fault domain 1. Let's say if I add 10 machines, then 5 machines will have fault domain 0, 5 machines will have fault domain 1. So that's what I meant. Okay. So now what I'm going to do is I said we're going to create a load balancer, right? So before that we will enable IIS on both the VMs. Okay. So I'm going to connect to the VM number 1, right, and I'm going to enable IIS. Okay, so I will add a network load balancer now. I will just say I'll go to marketplace, I'll click on new, and I'll go to networking. Okay, I'll say simply say load balancer. Okay, I'll click on load balancer, I say create. So this is a new component. This is a new component outside of the VM. I'll say my load balancer or something, or my LB. So there are two types of load balancers. One is a public load balancer, one is an internal load balancer. So if you go back to the diagram, the public load balancer is actually having a public IP address. It is directly interfacing your customers. So your web servers will be ideally under public load balancer. So there could be another component called internal load balancer, which I am highlighting here, right? So this one is more like an internal component. Let's say your web servers wants to access data from the database servers, right? Multiple database servers. So this this load balancer acts as a failover for these database servers. So and this load balancer is not accessible to the customer because this doesn't have a public IP. So the only difference between public and internal load balancer is the public load balancer has a public IP address. The internal load balancer is part of your virtual network. That means it will have a internal IP address. It will not have a public IP address. So I will say load balancer IP. So I'm asking for one more public IP address which will be assigned to the load balancer. So I'm giving a name, I'm selecting public, and I'm assigning one. I'm assigning one public IP address, and I will simply enter the name of my resource group, and I'll select a location, right? So this is all you need for creating a load balancer. Okay, now the load balancer is created. If I go to the load balancer, I have 5 important options here that you can see on the screen. In the settings, we have front-end IP configuration, back-end pool, health probe, load balancing rules, and NAT rules. We will look at each of these options. Okay, first we'll go to front-end IP configuration. Front-end IP configuration is nothing but the public IP address. So this is called as the front end of the load balancer. This is called as the back end of load balancer. Here you have public IP address as your front end. So that's what we define, right? So in the front end of the load balancer, we have LBIP, which is nothing but your public IP. So in backend pool, you will add your VMs, whatever VMs you created, right? Server 1 and server 2, you will add it here. So I will give a name for the backend, and I will say availability set, and I will select set 1, and I will add each of the machine, right? So do something like this. So I have multiple machines, right? I will do this. So I will add server 1 and server 2 both under this pool. So basically I am creating both my machines under the load balancer. Okay, so this becomes the backend pool. So front end is the public IP address which will be assigned to us. Backend is the pool that I am adding now. So these two are the pretty much very important, right? So this, once it is done, we'll go to the health probes option. Okay, so the backend pool is successfully added. So as you can see, both the servers are showing as running. So I've added the 2 machines as the backend pool, and now I'm going to define one health probe. So what is a health probe? I said our load balancer will have to monitor the VMs, right? If there is a VM which is gone powered off, or which is shut down, or anything wrong with that VM, your load balancer should be able to detect. How does it detect, right? So that's why you have to create a health probe. You may call it as probe 1 or whatever you want it, and it can monitor both on HTTP protocol or TCP protocol, right? And you can enter a port number where you want to monitor. If you simply mention 80, so port 80 is where the machine will be monitored. And how often it is monitored, it is we can define it. Let's say you mention 30 seconds here, so every 30 seconds the load balancer sends a ping to that server, right? And you can mention how many times it can sustain the failures. That means if you mention unhealthy threshold as 2, the load balancer will tolerate 2 failures. That means first time it sent a request, the machine did not respond, it is fine. Second time, again after 30 seconds it will try. If the machine doesn't respond after the second time also, it will make that machine as bad. So if you have a slow server, or if you have a slow network, you can increase this number, right? You can increase this number so that you will not have any false alarms, right? So if you keep this number low, you should make sure that your servers are fast and your network is also fast. You can reduce the interval at which it should do monitor. That means if you, let's say if you make it 60, then every 60 seconds, that is every 1 minute, it will send a request of what? A health check request. That means both the machines will be getting health check request every 1 minute. So that's what I defined just now, right? So this is going to create the probe, and once the probe is done, we will go ahead with the load balancing rules. So that will be the last step of the load balancing process. Okay, the probe is created. Now we'll move on to the next step, that is load balancing rules. Now what we do here is we create a rule and mention how do we like to load balance. So simply what we are doing is we are utilizing the settings whatever that we created. So if a request comes in at this public IP address, right, you send it to so and so port, and which machines are running there, right, and what health probe need to be used. Okay, that means let's say your website, let's say it is hosted on 50,001, right? So you will not ask your customers to enter flipkart.com/50,001. So what you would do is you will create a rule in your load balancer saying that port 80 is the incoming port, backend port is 50001. So if a customer enters flipkart.com, that means by default it is port 80, the request is routed to 50001 because your backend has website running on 50001. But if you don't have any custom port like that, you can simply go with the default value. Okay. And session persistence is one option which will remember the clients. That means let's say if customer A has come in for the first time and you give him one of the machine from this pool, that means let's say server 1 is given to customer 1. Okay, now within this timeout period, that is 4 minutes, if the customer refreshes the page, that means or he comes back again, so if you enable this session persistence option, then the load balancer will give him the same machine, that means server 1 only. If you don't have this session persistence enabled, then the load balancer might give a different machine, right? So this setting will simply enable the load balancer to remember who is requesting the server, right? So if the same person or the same machine IP comes within this specified time duration, then the same server which was given previously will be assigned again, provided that server is healthy now. That means if server 1 was allocated 5 minutes ago, and if the customer is coming within 5 minutes, if server 1 goes down within that 5 minutes time frame, then it will not be given. But if server 1 is healthy, then it will be given, right? There is a reason behind that. Why? Because the server 1 already has the customer profile loaded, right, on the server memory. So it will be much faster for the customer to use the same server instead of assigning to a different server, right? So his profile is already loaded there, so it is sitting in the cache, so it will be faster for him, right? So that is the whole purpose of enabling session persistence, right? So this is not a new thing, it is there in IIS also. So yeah, you can use the session persistence for performance benefit. Okay, so now we'll go to the last option, inbound NAT rules. Or instead of that, what we'll do is we will test if our load balancer is working fine, right? So okay, load balancer has a public IP, right? So we'll give a name for this one, we'll give a domain name for this one. Okay, instead of customers using the IP address, we will use a name. Okay, so what I'll do is I will go to the load balancer IP address and I will put one name. So I will say my Flipkart test or something, because it needs to be unique, right? So I will save this. Okay, so I give a user friendly name, so I will simply use the user friendly name. I will say .southeastasia.azure.com. so I will enter this. So you see this, right? I am using the IP address of the load balancer. I am getting a response from server 1, so I will keep hitting this server and I will get a response from server 1. But what happens if server 1 goes down, right? So what we'll do, we will try to simulate that, right? We'll go to server 1 and I will shut it down. Let me stop it. Okay, I will stop this. Okay, so I'm stopping the server 1. So let's go and look at the health of it. I'm going to my load balancer. I'll go to backend pools. If I expand, so machine is stopped. So if I hit the load balancer now, you can see, right, now it is going to server 2. So at the customer side, he need not worry that server 1 or server 2. He doesn't even know that there are multiple servers. So we have two servers and both are running the same program, and one of the server is down, which was serving the customer. But now if the when the request is refreshed, I'm getting the server 2. So I'm not asking customer to use a different URL, right? Different URL of server 1, different URL of server 2. My URL is fixed. Backend, even if it goes down, my load balancer is helping me sustain, right, or helping me run the business. Okay, now we'll look at the last option, that is inbound NAT rules. Okay, now this one helps you get to or connect to the machines, right, directly. That means let's say you have 10 servers in your backend and you want to RDP into those 10 machines. So ideally what you have to do is you have to get a public IP address for all of those 10 machines, which is practically not the case in the companies, because public IP address will not be given to you, right, for each machine. So in this scenario, what you can do is you can make use of the load balancer public IP address and connect to the machine. So to do that, you have to create a rule, right? So let's say I want to do RDP to machine 1. So I will use load balancer IP, which is this one, and what I will say port number 3389, and I want to connect to server 1, and target port is 3389. Now if I do that, if somebody uses this load balancer IP from RDP, he will connect to server 1. But what if you have more VMs, right? So 3389 will be used only once. So what I'll do, I will give my own custom port number. That is, let's say I want to give 5001 for server 1. Okay, that means if somebody uses load balancer IP colon 5001, he will be connected to server 1, right? So that's the point. Now I will add one more rule, and I will say 5002 as the port number, and I will make that route to server 2. So we need to create one more rule. So if you have 10 VMs, you need to have 10 rules in that case. So this is the peer-to-peer kind of rule. So if you want to SSH or if you want to do FTP, you can all add the required number of rules. So you can go to this and you can see, right, you have different protocols. You can host an FTP server on one of the VM and run through the load balancer IP. You can do that. So 5002 I want to route to server 2, and custom, and I will say 3389 is my target port, right? So target port remains same, because when it is going to the VM, it converts back to 3389. But when you are requesting, you are differentiating which VM you want to connect to, right? So I will say okay. Okay, I'll pause for some questions here. I think I've been talking for almost 1 hour. Let's test the NAT rules also. So the load balancing IP is this one, right? So I'll take the load balancer IP. Okay, I'll take this IP. I'll go to my remote desktop. I will put this, and I will say 5001. Now I expect my load balancer to route me to the machine 1, right? Let's see the second one. Okay, so my VMs already have a public IP, so I will drop that public IP from the VM. Let's see if this is causing a conflict, right? So I will drop the public IP of the VMs. Okay, now I'll go back to my load balancer. I'll go back to NAT rules. So I have two NAT rules. Okay, target machine is server 1. I will save it. Okay, I will save target machine as server 2. I will save it. Okay, I'll come back to NAT rules. Okay, so we need to select the machine as well as the network adapter name also. So I'm selecting that. So let me resave that again. Okay, now I will do that same thing for the second machine also. As I save. So basically what we have done is we have done this half, right? So we have done this part. So we have done this. So this is my load balancer, and I created one machine, second machine, and I've done this setup. So my customer is sending a request, one of the server is responding. So what I did, I disabled this server. So whatever request that was going to this server, right, it will now go to the second server, this server. So my customer is not getting impacted, right? Whoever is sitting here, right, he is not getting impacted. Though first server is responding, second server is responding, he doesn't care. As long as the website works for him, it is fine, right? So that's what we did. Okay, so let me go back and see. Now the assignment is now proper. Now let's try this. Now go to MSTSC, use the load balancer public IP. I'll say 5001. Now let me see. (2086). This is right. Custom port is 5001. This is fine. Target port is 3389. Okay. Let's see what else is wrong. I go to my backend pools. Okay, server 1 is in stop state, right? So I'm trying to connect to that server. That is not right. Okay, so I will connect to second machine. Instead of 5001, I'll connect to the second machine, which is 5002. Yes, now this is connecting, right? So I'll go to test user at 123. See who is receiving the request. It is server 2, right? So my NAT rule is working. That means if I use the public IP of load balancer, I'm able to reach the server which I mentioned in the rule, right? So if I say yes, I'll be connected to the second server, right? So I will start this first server also. I will invoke this server, and once it is started, we should be able to connect to the first server also. Okay, so that was the concept of the load balancing. So what we did, we created two VMs and then we created a load balancer. We added these two servers under the load balancer, right? And then we defined a couple of rules, how to monitor, how to connect and all that. And then we finally give the URL to the customer. Which URL? Will give the load balancer URL, not the server URL. We give the load balancer URL. That is, let's say this is your flipkart.com URL. You give this URL to the customer. So backend, it is going to one of the servers, right? Whichever server is healthy and available, it will go to that server, right? So your customer is least bothered about which server is responding and who is serving my request. So now let me try RDP to the first server also. Okay, now let me copy the public IP. Let me take the load balancer public IP. I'll go to load balancer. I'll take the public IP of load balancer. I'll put it here and I'll say 5001. Now it should connect me to the first server, right? Okay, see this, it is connecting to the server 1, right? So that's how you do it. Okay, Sai, I'm going to end the class here, and you can get back to me on WhatsApp or either email in case you have any issues with the load balancing which we discussed today. Okay, okay, Sai, so that's all I have then today. Thank you. Bye.